Imagine a smart home where your lights, doors, and thermostat all work together to make life easier, turning on when you need them, adjusting automatically, and staying connected. This is exactly what my smart home automation system does, using C# and object-oriented programming principles. Hi, this is my submission for Task 1.5D Help Others, and I'm going to walk you through how this system is built, demonstrating key OOP concepts like encapsulation, abstraction, interfaces, inheritance, polymorphism, and delegates. Let's start with this interface. Controllable. An interface defines a contract. It says any class that implements this must have these methods and properties. Here, every smart device must have activate, deactivate, a name, and is on status. Interfaces help enforce consistent behavior while allowing different devices to implement those behaviors differently. Now here's the abstract class smart device. It implements the interface and defines shared properties like name and ISON that are encapsulated, meaning they're kept private or protected to prevent unauthorized access and modification. You can only change or read them through specific methods or properties. The class also declares abstract methods activate and deactivate. This is abstraction. We define what actions must be done, but leave the details to subclasses. Now let's look at one of the concrete device classes. For example, Smart Light. This class inherits from Smart Device, which means it reuses the common code defined in the base class. That's inheritance, allowing us to extend and build upon existing functionality instead of rewriting it. Inside Smart Light, we override the activate and deactivate methods to define what it means to turn the light on or off. This is an example of polymorphism. The same method names, like activate, behave differently depending on the device. Whether it's a light, a door, or a thermostat, each one can have its own custom behavior while still following the same interface. Now let's talk about delegates. In this project, I've used a delegate to handle events, specifically when a device is activated. I created a delegate called Device Activated Handler, and whenever a device is turned on, it triggers a method that logs that activation. Delegates are like function pointers. They allow us to pass methods around and call them dynamically. This brings event-driven programming into our system, making it more interactive and responsive. Finally, let's run the program. Here you can see the main menu of the console app, where I can list all smart devices, activate or deactivate them, and view their current status. I'll activate the living room light, and as you can see, the device turns on, its status updates, and a delegate method is called to log this change.